What you do, sixth graders? Hey, happy Wednesday. I'm going to go over the answers in the book for all of those students that are total remote. Remember cohort A and cohort B. I'm not going to be posting this video until after I've checked whether you've already had it done. I'm not going to go back and put check marks in there so we just know who's doing the work and kind of who's not. So we read the first part of lesson 1 on speed and velocity, and we're going to figure out how to calculate speed and how do you describe this velocity. So highlighted here and down here, we're going to apply some speed and velocity. Now, if you remember when I was talking about to calculate speed that you have to divide the distance by the time, and this is an equation, and that's what the answer here is. That relationship can be written as an equation. When we first talked, when we were doing the highlighting, I started talking to you about, well, this equation, it enables us to find a different, and I sort of cut myself off and I said, well, I'm getting ahead of myself. So I'm going to pick up on that idea now. So here it says draw arrows. So I'm going to follow the directions. And it draw arrows, and it tells me the cyclist shown in the diagram is moving at a constant speed. We talked in class what a constant speed is, and people said it didn't. They were not slowing up, and they weren't slowing down. Slowing up? I guess speeding up would be better. 10 meters per second. So after 1 second, they would be at 10 meters. And 2 and 3, those were pretty easy. 3.5, most of us got that. But then a lot of us, unfortunately, skipped the challenge. And the challenge was, how long will it take the cyclist to travel 400 meters? So let's go back up to this equation here. And we have the speed equals distance divided by time. And when you're learning how to find speed, it seems like they're always giving you these numbers. And I think that that's why it's a challenge. Because in the challenge, they gave you the speed, they gave you the distance in the word problem here, and now they were asking for the time. And we talked in class about about fact families that we learned about and how to figure sort of that out. And I kind of just said what I used to do if I wasn't sure, I would make up a problem that I really knew the answer to already, a real simple one, sort of like 2 equals 6 divided by what? What does that equal? So we all know perhaps that this is 3, and I just know it's 3. Well, once again, when we were describing motion, I know that you know that it's 3, but how could you prove it to me using the information that you were given? So I was given a 2 and a 6. How could I get 3 doing that? Well, I would have to divide 6 divided by 2, and that works over here. 400 divided by 10 equals 40, and that's how long it would take them, 40 seconds. So those are the answers for that, and I'm going to turn the page here. We also did this in the, you know what, let me get the camera put up just a little bit so that we can look at both of these pages sort of together. Now, I don't know, I think I'm going to stop going over these in class and actually just do this in the video and ask you to check your answers against what I put in the video. So I said in class here, using this, there's 2 athletes and they want us to calculate the average speed. And I said, you know what, when I have to find it, I'm always going to write that equation, speed equals distance divided by time. That's going to help me. So when I go down here, they've given me the distance and they've given me the time. I gave everybody a calculator and we did 3 divided by 0.8 and got this. I always like those units written there. I did 3 divided by 1. We did not use the calculator for that and got 3. Looking at these, we would know the triathlete won the swimming because they were faster. I also said if you're really smart, though, you want to take note because if this were time, this were only, let me cover up those K's. If this were only hours, then we would say that B won because B did it in less time. So you got to watch what they're asking for. You got to be one of those clever students that actually read all the information, maybe more than once, especially when it comes to the question. Okay, we repeated the same activity here with the biking, in which we took the distance of 50, divided it on two separate numbers, and realized that activity B here, or activity, excuse me, triathlete B won this because he was traveling at 20 kilometers. We also did a mini math lesson about what that bar over the 6 means. It means the actual number here was 16.666666666, and so on. Okay, so a lot of the students in class looked at the running and thought that we were doing the same thing that we did over in these two, because maybe they didn't read the directions, like I said, maybe more than once, that it wanted you to find from all 3 legs. So if I'm going to find the total distance of all 3 things, then I would have to add 3 plus 50 plus 12, and that would be 65 kilometers over this whole triathlon. So triathlete A's total time, I would have to go time here, and time here, and that came up to 5. And then once again, I'm doing that speed equals distance divided by time. So I'm going to do 65 divided by 5 equal their speed, which was 13. I did the same thing for triathlete B, and they did it in a little bit less time, thus making B a winner. Now, instantaneous speed is highlighted up here. If you looked at my notes on Google Slides, I have a speedometer by the term instantaneous speed. So the speedometer in a car gives the car's instantaneous speed. You want to take advantage of these questions that exist in a textbook. It's been a long time since I've been in college, but when I was in college, there was maybe a couple of review questions in the back of the book, and I think I should have paid a little bit more attention to those, because I think a lot of the test questions are connected to that. I looked at the paperwork for lesson 2, and this is a question. So that's why I put it on the notes. That's why I make sure that I highlight it here. If you want these other answers for you too, in an instant, instantaneous, and the average speed is over a longer period of time. Someone had an excellent question. They did a question about, well, if I'm going to find their average speed, why can't I take the average here and the average here and the average of their running, which is 10, and get all those together? And they got 30. Now that was all of their speeds added up. So I knew that wasn't a right answer. So like if I went 55 mile an hour to, let's say, Boardman on the highway, and then the next day I went 55 mile an hour, my average wasn't 100 miles an hour. We would have to divide that by 2. So I know I would divide it by 3, and it comes out to a 10, not 13. So I know that we're finding the average of average speeds, these numbers, and not the average speed overall. But why it doesn't come out the same is, I guess I would say, over my pay grade. I've actually called some other teachers to see. I do know that 10 is the average of the average speed and not the total average speed of all of the activities. So there's those answers. We're going to finish and talk about velocity a little bit. That's kind of what you're supposed to be working on now. I think some of us have read those pages and answered those questions, and I'll be checking to see if these are done later on. We're going to do a little bit more in depth about interpreting graphs. So I'm going to set that aside, and I'm going to talk a little bit about this activity here. Now, remote students, I'm going to plug on there a video that you're supposed to watch, and she gets into a little bit more detail than we're going to in 6th grade, but if you're listening to this, you're going to be doing this on Thursday. And if you don't kind of get this, hopefully you'll be able to watch this video and see. And then cohort A and B, we ran out of time. We're going to pick it up a little bit later, but maybe you can see what we're doing here, and I'm going to bring this down a little bit, that what we did is we gave some kids a timer, and in number 2, it asks you to walk 5 meters. So if you want to do this at home, remote students, 5 meters is probably about 15 feet, so you might have to do it in your living room. You could use a yardstick if you want to mark it off, 2 pieces of tape, and use your phone and say, how long did it take me to walk 5 meters? Now, I'm a little bit of a slow walker, so it took me 6 seconds. And then this is where it gets confusing, because now I'm just going to give you 5 seconds and see how far you walk. Some kids walked 5 meters in 5 seconds. So when I gave them 5 seconds, their answer was 5 meters again, and they thought it was sort of wrong. And I'm like, no, you guys are right. Just write it down. So I told you I walked a little bit slower. So in 5 seconds, believe it or not, I only walked 3.5 meters. So you can use my numbers if you want. Now, what number 4 asks us to do is to repeat this, only instead of walking in a normal pace, we're going to walk slowly, and we're going to slowly measure 5 meters, and then we're going to see how far 5 seconds, and then we're going to do it again fast. So if I walk fast, how long does it take me to walk 5 meters? And in given 5 seconds, if I walk fast, how far? So you can see that this is I'm collecting time, and this I'm collecting distance. Now on the actual paper that comes with it, this information isn't there. And I thought it helped me knowing I was supposed to record seconds, walking slow and walking fast. And over here, I'm already given my time, which is 5 seconds. See how far I'm collecting a distance. Here was only 2 because you're supposed to slow down. And here I was supposed to speed up. Just so you know, some of my 5th graders walked 10 and 11 and 12 meters. So they walk a lot faster than me. So now that's all the information we have to collect. Now we have to do some math with it. And I am going to write this down. If you want to use my information, you can. If you would like to see what your normal pace speed is. So let's see, my normal pace, it took me, here's 5 meters, so they're looking for time. So I'm going to go and I'm going to write what I wrote for number 2 here, and I'm going to write 6 seconds. And then in step 3, they gave me the time, which was 5 seconds, and said, how far did you walk? So you can see that the blank, we're filling in the parentheses here, was 3.5. In fact, cohort A and cohort B, I ran this paper off again, so I was able to adjust it so it was straight. So now you want to practice doing your speeds. So I'm going to do, it's always distance divided by time. So I'm going to do 5 meters I walked. It took me 6 seconds. So my speed was actually 0.83. I'm going to put that bar over there because it repeats. And now I'm going to do my how far I walked, and they gave me specific 5 seconds. So I'm going to do 3.5 meters divided by the 5 seconds, and it equals about 0.7. So you can see what my average speed is pretty close. You shouldn't have like a real big number and a real small number. They should be relatively close. So my normal speed is somewhere between 0.7 of a meter per second and 0.8 of a meter. 1/10 of a meter, you got to figure is what? A meter is 100, so it'll be about this much difference. So now this is what's kind of confusing because we're going to do the same thing with slow and fast. So all you have to do is take these numbers that are up here and put them down here. I'm not going to calculate my fast and slow speeds. Okay, you're going to have to do that. But we are going to, if you cover up the speeds, the ones that look like mumps, okay, cover those up and move these numbers down. So 8's going to go in the first one, 4.5 is going to go in the second one down here. I'm going to move over here and put 2 and 6.5. So now you're going to have to, the problem's right there, 5 divided by 8, 5 divided by, I think it is 4.5. And then you're going to write the speed that you get. And then same thing here. So my slow speed should be pretty close. My top two numbers should be close, and my bottom two numbers should be close to each other, but not to the top line, because the top line is when we're doing slow speed, and the bottom is fast speed. The only difference is here we were given a specific distance, and we timed ourselves, and here we were given a specific time, and we recorded the distance. That's all. And then this asks you to, you could probably answer this just reading it. Let's think about what it says. Describe the relationship among the distance you walk, the time it takes you to walk, and your walking speed. So all you got to ask yourself is, if I speed up, what's going to happen to the distance I cover or the time? That's sort of. And then some of you, I think cohort B is on Thursday, it asks you to do the back. If me covering this, and you have this information up here, I kind of switched it on the back. So if you're a B person, it asks you to complete this. Don't worry about it. You can try it if you want and impress me. But we can come and hopefully I'll catch that up with you. And then we're going to do a graphing speed worksheet, because the following week we've really got to talk about how we graph. And we're just going to do this activity in class. So I might adjust my lessons a little bit. So if you're looking at my site. So I hope that helps you. That's a big, long video. I'm going to post it today. And remote people, you have the information. Don't get hurt. Don't get worried over here. When I was walking my normal rate, that was number 2. What was number 2? What was my distance? This was number 3. So this was number 4 you're going to figure out, and then you're just going to kind of take what you're putting in this here, and you're going to write it in a table here. Because in science, we often collect data, put it in a table, and then we graph it, especially in physics. Okay, what you do. Thanks for watching my video, and I'll see you guys later on in the week. I'm out.